The Papillon system leverages dspy's modular architecture to orchestrate privacy-preserving delegation between a local trusted model and an external untrusted model, employing signature-based task definitions and chain-of-thought reasoning to balance response quality and information leakage. We will now examine how the system initializes this pipeline and evaluates its zero-shot performance on the development set using a composite metric that weighs both response quality and privacy preservation.
Zero-shot equals papillo nuntrusted model equals OpenAI LM. Quargs equals dictum threads equals 16. Display progress equals true. Display table equals 5. Max errors equals 100. Evaluate equals dspy. Evaluate metric equals compute overall score. Devset equals devset asterisk quargs. Evaluate zero-shot.
This code evaluates the zero-shot performance of the Papillon system on the development set using the defined metrics. The Papillon system is a framework where local models, which are trusted but offer lower quality, can use external models untrusted but more powerful as tools to improve user inference time privacy. The evaluation process involves creating an instance of the Papillon system with the untrusted model set to OpenAI LM. The dspy.Evaluate class is then used to evaluate the system on the development set devset using the compute overall score metric. The evaluation is configured with specific parameters, such as the number of threads, progress display settings, and maximum errors allowed. The compute overall score metric is designed to assess the overall performance of the Papillon system by considering both the quality of the responses and the leakage of private information. This metric is crucial for determining the success of the Papillon system, as it aims to balance high-quality responses with minimal leakage of private data to the untrusted external model. Let's break it down line by line.
Zero-shot equals papillo nuntrusted model equals OpenAI LM.
Creates a Papillon instance named Zero-shot, configured with an untrusted OpenAI language model, OpenAI LM, as its external model component. The instance will use this untrusted but powerful model as a tool while maintaining privacy constraints through the Papillon framework's design.
Quargs equals dictum threads equals 16. Display progress equals true. Display table equals 5. Max errors equals 100.
Creates a dictionary named Quargs with 4 key value pairs that configure execution parameters. Sets the number of threads to 16, enables progress display, configures table display to show every 5th entry, and limits the maximum number of errors to 100.
Evaluate equals dspy. Evaluate metric equals compute overall score. Devset equals devset asterisk quargs.
Creates an evaluation object using dspy's Evaluate class, configured with a custom compute overall score metric and a development dataset devset. The quargs parameter allows passing additional configuration options to the evaluator. This evaluator will be used to assess the performance of the Papillon system by comparing local model responses against target responses while minimizing PII leakage.
Evaluate zero-shot.
Calls the evaluate function with the zero-shot parameter, triggering an evaluation process that assesses the performance of a zero-shot configuration in the current context. The function likely executes predefined metrics or tests to measure how well the system performs without prior examples or fine-tuning, returning results that quantify effectiveness based on the Papillon framework's success criteria. The Papillon system demonstrates how to balance response quality and privacy by delegating tasks to an untrusted but powerful external model while maintaining control through a trusted local model. The evaluation pipeline starts by instantiating Papillon with the untrusted OpenAI model, then configures the evaluation environment with thread management, progress tracking, and error handling. The core of the evaluation uses dspy.Evaluate class with a custom compute overall score metric that simultaneously measures response quality against target outputs and quantifies privacy leakage in terms of PII units exposed. This composite metric directly reflects Papillon's dual objectives, maximizing response quality while minimizing information disclosure to the untrusted model. The evaluation process itself becomes the feedback mechanism that will later drive optimization, as the same metric used here will guide the GRPO optimizer to refine the system's performance.
The evaluator threads hum while metrics evaporate. Yet progress bars count their absence with perfect precision.